All right, we're back. We are still on page 3 of notes 3 of Calc C, and we are now going to talk about, so we're talking about sequences in general. We've been talking about, do they converge? If a sequence converges, it just means that over time, as the term number increases, the terms approach a specific value. So we saw examples where they approach 0, where they approach 1, where they don't approach anything because they start alternating between two values. We use a calculator to generate the terms of the sequence, which is great because generating them is super annoying. So the next thing we want to talk about is something called monotonicity. So a sequence is monotonic. Monotonic, so like one tonic. Or monotonous is probably a word that, you know, when people used to watch Ferris Bueller's Day Off, they had a better sense of what monotonous was, because like when Ben Stein is his teacher is trying to call him in class, it's just like Bueller, Bueller, Bueller. He just like keeps repeating it. It's very monotonous. So a sequence is monotonic if its terms are non-increasing or non-decreasing. So non-increasing means that the next term from the one that you're on is never bigger than the term that you're currently on, right? So it might be the same. So you go like non-increasing. You go 10, 10, 9, 9, 8.9, just keep getting smaller or staying equal. So it's non-increasing. Or you could be non-decreasing, which means that no matter what, you're never going to get a smaller value as you move from left to right through the sequence. So in general, in sort of mathy terms, if a function is non-increasing, it means that a1 is bigger than or equal to a2. a2 is bigger than or equal to a3. You just can never increase. Like a sub n plus 1 cannot exceed a sub n. That's what it means. So that's monotonic. It's always doing the same thing. It's either staying the same or decreasing. Non-decreasing, same thing. So it's either staying the same or it's getting bigger. So we want to figure out if some functions are monotonic. We know a way of doing that, right? Think about increasing and decreasing. What do you know about increasing and decreasing? Well, if we have a function, a continuous function that we can deal with, if that derivative of that function is positive, then the function is increasing. If that derivative is negative, then the function is decreasing. And then we just need to worry about like really greater than or equal to 0 or less than or equal to 0, because you could stay at the exact same level. You could be non-decreasing or non-increasing. So let's see if we can work these out. First, I'm not going to use a derivative on this. I'm going to say that I don't really know, but the terms alternate between 2 and 4. So not monotonic. Right? I mean, there's no way, right? Because if the first term is 2, the second term is 4, so it increased. So you can never decrease if you're going to be monotonic, but then the next term is 2 again. So like no chance. That had no prayer. Now this one, we actually have the terms up above, n over 1 minus 2n. We have the terms up here, right? So it goes -1, -2/3, -3/5, -4/7. So we're approaching -1/2. This is monotonic, but what I want to do, well, I think it's monotonic. What I want to do is actually say f of x is x over 1 minus 2x. Therefore, a sub n is equal to f of n, right? So like now we have a function we can work with. I'm just using the calculator. So I'm going to say, let's see, switch in. All right, so f of x is x over 1 minus 2x. And then I'm going to take the derivative, which you should use the template for, derivative. And then you can see this derivative is always going to be positive as long as x is bigger than 1/2. Well, I mean, this derivative is always positive, but the function itself is not going to be continuous. So I'm going to say f prime of x is 1 over f. Why am I so surprised by how nice f prime is? I don't really know. 2x minus 1 squared. Okay, so let me go back here. I'm going to say, because we gotta clean up and make sure that we're doing like good work. That's really like the stumbling block, is greater than, I'm going to say greater than or equal to 0 for x greater than or equal to 1. And then let's say, therefore, a sub n plus 1 is greater than or equal to a sub n for n greater than or equal to 1. Therefore, the sequence is monotonic. That's the best I've ever chosen to write up that answer. Let's take a look at the next one. Same deal. So I'm going to define a function. So we have the terms of this. It's actually less clear to me, even just looking at the terms. Like 1 and then 4/3 is bigger. And then 9/7 I'm pretty sure is smaller. So it like increases and then decreases. So this should not be monotonic. So let me define my function and then take a derivative on the calculator. So we'll do x squared over 2 to the x minus 1. So a sub n equals f of n, right? So we've connected them. Now I'm going to find f prime of x using a calculator. It's like quotient rule and the derivative of an exponential. It's got natural logs in there. It's going to be gross. So let's see. F of x, we're redefining you, is x squared over 2 to the x minus 1. Okay, so derivative. Let's just go grab this. Okay, I'm going to ask this to solve. Solve the answer greater than 0 for x. I'm just going to get it to solve. Let's see. No dice, really. So it basically like spits out a bunch of equations at you. You know what I'm going to do? I'm going to graph it. Here we go. What am I going to graph, though? I'm going to graph the derivative of f of x. So there you can see it, right? So there's a sign change there. What if I ask it to solve equals? What do you do then? Like, can you find the values? There we go. Okay, so equals 0. And then we can do like a sign chart, sort of, right? I just need to know at 1 and then something bigger than 2. So where's my thing? Here we go. Such that x equals 1. And then 3. Okay, so f prime, do I really want to write down f prime of x? I mean, all right. I'm handwriting this right now. I don't really want to do that. I'm going to go back and find a better way to write this up. Here we go. That's what you should do. You should always be thinking, like, what's the good way to write this? I'm going to say f prime of x changes sign at x equals, let me go back to the calculator. I'm not going to make you watch. I'll just like go back and find it. So at 2.299, 2.299, therefore, f of x is not monotonic. Therefore, the sequence a sub n, holy cow, what is going on with these braces that I'm trying to write, is not monotonic. So what's weird though is like, that's a hard word. What's a little weird about this though is if we had just chosen to start at 3, start your series, the sequence, start your sequence, dang it, start your sequence at n equals 3, and it is monotonic. So like it's very dependent on where you start. And I don't know. I mean, like sometimes you can make that choice, sometimes you can't. But if you start at 1, no, start at 1, not monotonic. So not monotonic, and you're done. All right, one more. So I'm going to say f of x equals x plus 1 over e to the x. Therefore, a sub n is f of n. f prime of x. This one, it seems like it'd be easy enough to do by hand. Bottom derivative of the top minus top derivative of the bottom all over the bottom squared. I mean, I just don't want to. Calculator. To go with the calculator, right? Like we're learning concepts. It's not about grinding out those derivatives right now. F of x is x plus 1 e to the x. I mean, if this had been the first video I made today, then maybe I would have done that. All right, derivative. You always want to reuse every, oh my gosh, the derivative is so nice. So the derivative, let me just handwrite that in. Negative x e to the negative x. So the derivative only changes sign at x equals 0. So this thing is monotonic. Let me solve this. I don't know, greater than 0. No, well, I mean, it's definitely less than 0 for x. As long as x is, so I'm going to say, let's go back. I have a Taylor Swift song stuck in my head. I have I think mean. Why you gotta be so mean, or whatever it is. It gets stuck in my head sometimes. Not sure why. So this is less than 0 for x greater than 0. Therefore, I'm gonna just say the sequence is monotonic. And there we go. I'm excited about that one. So like they're not that bad. I mean, the hardest part is finding the derivative, seeing if the derivative is positive or negative, remembering to write a really nice solution. But anyway, I'm gonna stop this video here and be back in the next one, and we will talk about more stuff that has a little bit to do with being monotonic. So I will see you there.